Alright, so in this video, I'm going to solve the equation 1 to the power of x is equal to 2. So, before we even start solving this, if, let's say x is equal to 1, then I have 1 to the power of 1, which is equal to 1. And if x is equal to 2, then I have 1 to the power of 2, which is also equal to 1. And you can go even 1 to the power of 10 is still equal to 1. So you may be thinking, what possible value of x can make 1 to the power of x equal to 2? So let's try solving this. What I'm first going to do is start by taking ln of both sides. So I get ln of 1 to the power of x is equal to ln of 2. And ln is the same thing as the natural log. And the reason I took the ln on both sides is because it comes with a property that states that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln 2. And you may be thinking, we could just divide both sides by ln 1 and x would equal ln 2 over ln 1. However, the only problem with this is that ln 1 is equal to 0. And remember, anything divided by 0 is undefined, so this would be undefined. So we know that this equation has no real solution, but it could still have imaginary solutions. So to actually solve this, I'm going to use something known as Euler's formula. And basically what this formula is if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know to many of you watching this video, this may just sound like a bunch of gibberish, but just hang on. So let's say that theta is equal to 0, right? Say that theta equals 0. So now I get e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. Cosine of 0 is 1 and sine of 0 is 0. So I get this all is equal to 1. Now, what if we say theta is equal to 2k pi? And k is just a substitution for all real numbers. So now I get e to the power of I times 2k pi is equal to 1. Because all we did was we just substituted theta in for 2k pi into this same thing. So now, because this is equal to 1, we can remember our first equation, which we started with 1 to the power of x equals 2, we can substitute in this for 1, meaning I get e to the power of I times 2k pi to the power of x is equal to 2. So just think of this as 1. So I have basically 1 to the power of x equals 2. And now, with this, I'm going to take the ln, or natural log, on both sides. So I have ln e to the power of I times 2k pi to the power of x is equal to 2. So I'm going to now bring this x down using the property of natural logarithms. So I get x times ln e to the power of I times 2k pi is equal to 2. is equal to ln of 2, because if you take ln on one side, you have to do the other side. And now I can also move I times 2k pi to the front. So I have I times 2k pi times x times ln e is equal to ln 2. ln e is simply equal to 1. So I get x is equal to ln 2 over I times 2k pi. And now I'm going to multiply this by I over I. So I get x is equal to negative I times ln 2 over 2k pi, because I squared is negative 1. So this is my solution. Alright, so in this video, I'm going to solve the equation x to the power of 4 minus 16 is equal to 0. So my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. What I'm first going to do is rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 16 is equal to 0. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2 is equal to x to the power of 2 to the power of 2. And I have this minus 16 is equal to 0. Now from here, I'm going to rewrite 16 as 4 squared. So now I have x to the power of 2 to the power of 2 minus 4 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 4. So this turns into x squared plus 4 times x squared minus 4 is equal to 0. Now I can divide this into two equations. I have x squared plus 4 is equal to 0, and x squared minus 4 is equal to 0. So for x squared plus 4 equals 0, I'm going to subtract 4 on both sides. So I get x squared is equal to negative 4. And now I'm going to take the square root on both sides. The square root of x squared is simply x. So I get x equals the square root of negative 4. Now the square root of negative 4 is the same thing as the square root of 4 times the square root of negative 1. And the square root of negative 1 is equal to I, so I get x is equal to 2i. And this is positive or negative. Now for x squared minus 4 equals 0, I'm going to simply add 4 on both sides. So I get x squared is equal to positive 4. And now if I take the square root, I get x is equal to positive or negative 2. So my four solutions are x equals 2i, x equals negative 2i, x equals 2, and x equals negative 2.